Okay, so now we're starting off with geometric sequences, and there's going to be a lot of similarities to arithmetic sequences, except the pattern is different now. We're going to still use formulas. We're still going to use the explicit formula to find various numbers in a sequence without counting our way there one at a time. But the pattern is changing, so the mathematical operation is changing too. And let's start off with writing the recursive and explicit formulas. So as you remember from the arithmetic sequence, you start these formulas with an equals. That means any term equals, and it's related to the term before it. So in this case, any term in a geometric sequence is just equal to the term before it times r, where r is called the common ratio. Okay, and that's not how you spell common. Common ratio. Okay, and the explicit formula is similar. It looks like this. It's an, that's any term, equals the first term times the common ratio to a power. And the exponent right here is n minus 1. Okay, so there you have it. Those are the two formulas. Let's practice using one of them. We have this example here, and I'm going to say if an, that's the explicit formula, or the formula for the nth term, if an equals 4 times 3 to the n minus 1, what's r, what's a1, what's a2, what's a5, and so on? Well, take a look at this formula, the explicit formula, and compare it to what we have here. When you see an n minus 1, that's a dead giveaway that whatever the exponent is operating on is your ratio. So we have it right there, r equals 3. And a1, look at this, a1 is whatever is multiplied by that thing called r to the n1, okay? Whatever's in front of the parentheses, so that's a1. Now, if you have some example where there's nothing there, okay, I'm just going to change this for a moment. Bear with me. Let's say there was no number there. What would a1 be? Well, remember, when you don't see a number, that just means the coefficient 1. So keep that in mind. But that's not what we're dealing with here. We have a1 equals 4. Okay, so what's a2? Well, you can either use what you know from the recursive formula, which is that any term is equal to the term before it times r. And you can say, okay, well, a1 is 4. That means a2 is just 4 times 3, so that must be 12. Or you can actually plug it into the formula. I wouldn't for a2, but for a5, I might. Let's see, that's going to be equal to 4 times 3 to the 5 minus 1, which is equal to 4 times 3 to the 4th, which is equal to 4 times 81, which is equal to 384. Okay, so that's the basics of how you use geometric sequence formulas.